Distinguished viewers all over the world, welcome once again to Simplified Maths Class. I am your host, Mr. Mike Omeni. And please, if you have not subscribed to our channel, Simplified Maths Class, kindly do that by clicking on the red subscribe and the bell notification. God bless you as you do that. All right, today we'll be taking the topic angles of elevation and depression, part 2. In our previous slides, we have done angles of elevation as well as angles of depression, part 1, where we treated the one-dimensional problem, where either the angle of elevation or the angle of depression is just one. But today, we want to attempt a problem, a more challenging problem, where the angles of elevation or the angles of depression, as the case may be, will be two angles at the same time. And you'll be asked to find some certain parameters in the problem. Most times in exams, you meet such problems and you see students giving up. But we are here to show you how to do it easily in a very well simplified manner, so that anytime you see such a challenging problem, you will be able to do it without waste of time. All right, so let's take a problem. Let's say, for instance, a hawk P on top of a cliff H meters high observes that the angles of depression of two chicks, A and B, 25 meters apart, at angles of depression. Okay, a hawk P on top of a cliff, H meters high, observes that the angles of depression of two chicks, A and B, 25 meters apart, are 30 degrees and 60 degrees respectively. Full stop. Calculate, comma, correct to the nearest meter, or correct to the nearest whole number. I, the distance between B and the foot of the cliff, and I, the height of the cliff. All right, so we have a question on the board here. Now, the question says, take tan 60 degrees to be 1.73 and tan 30 degrees to be 0.58. Okay, so you've been given what to take as tan 30 degrees and as tan 60 degrees. All right, A. Maybe the answers are given and you're asked to find the correct one. B. C. And D. All right, so let's see how we can try this kind of a question. A hawk P on top of a cliff H meters high observes that the angles of depression of two chicks A and B 25 meters apart are 30 degrees and 60 degrees respectively. Calculate correct to the nearest whole number the distance between B and the foot of the cliff and the height of the cliff. All right, so we are going to bring out this problem out. Now this is the cliff, and there is a kite here on top of the cliff, and the kite is P. It observes the ground. All right, so this is what we have. This is a right angle triangle. Now, two chicks A and B. These are the two chicks on the ground, A and B. And the two chicks are 25 meters apart. All right, 25 meters apart should be large enough. Okay. Okay, it's okay. Let's have our 25 meters apart here, 25 meters apart. But I think this would have been 25 meters is a big one, so let's have it here. So this is B, and from here to here we have 25 meters. Okay, so this is a scenario, and now this is the horizontal eye level. That's the horizontal eye level of the hawk P. And now the hawk observes that the angles of depression of two chicks A and B, 30 degrees and 60 degrees. They are 25 meters apart. So we have 30 degrees and 60 degrees. Don't forget, of course, from here to here is 30 degrees. But from that horizontal level to down here, of course, here is bigger. So that will be 60 degrees. Those are the two angles. Here is 30 degrees on the first line, and on the second line, of course, the angle is bigger, and that's why you have 60 degrees. So if from here to here is 30 degrees, remember, these are the angles of depression, 30 and 60 degrees. But angles of depression here, of course, can be angles of elevation at the same time. I've explained that in our first slide for angle of elevation and depression. So if from here to here is 30 degrees, here to here by alternate angle 30 degrees, here to here will definitely be 30 degrees. And if from here to here is 60 degrees by alternate angle, it means from here to here will be 60 degrees. Please don't forget that, that's 60 degrees. If from here to here by alternate angle is 30 degrees, here will be 30 degrees. And if from here to here is 60 degrees where it touches this line, by alternate angle here will be 60 degrees. And of course, if you look at this question, you can now see that angles of depression is the same as angles of elevation. So in some problems, you might be given angles of elevation and you have this and this. So it's the same way we are solving the angles of depression. We'll solve for angles of elevation when you have two-dimensional problem. All right, so we've been told that they say we should calculate correctly the nearest meter, the distance between B and the foot of the cliff. So here is the cliff. So that's the foot of the cliff. And of course, this is where the hawk is. A hawk P, that's where the hawk is. So it's a simple problem here. Now, where we have the challenge here is that you have only been given 25 meters here. Of course, they told us here is H meters. So here is the height, H meters. They say the cliff that is H meters high. Now, you don't have any other value somewhere here or maybe here that you can be able to solve, because assuming we were given here to here, it's easy for us to use this place with the 60 degrees to find the height. After getting the height, you can now find A to C. It's just so challenging because you don't have any value here, you don't have any value here. So, men looking at this question, you might actually think that the question is an incomplete one because there is no sufficient data for you to find what you're looking for, which is here and which is here at the same time. But let me show you how you can do that. It's a very challenging one. You will always see it in exams, but it's quite easy to handle. All right, let's see how we can do that. Now, Please watch. All right, so let's consider the first triangle. We are going to consider the first triangle. So considering the small triangle, and the small triangle we have is PBC. PBC. Triangle PBC. Which of course is this way. So this is PBC. Here is the height. Let's call this place X. And then here is X. This is the angle 60 degrees. Considering this small triangle PBC with only that information given. Now, if you look at using SOHCAHTOA, you will see that the only three functional identity that relates opposite to adjacent, because we've been given the opposite as H and we want to find the adjacent as X. So opposite adjacent is only tan. That's why I say tan is the most widely used trig functional identity used in solving angles of elevation and depression in most cases. All right, so we have opposite and adjacent, we are using tan. So we are going to say the tan angle of theta is equals to opposite over adjacent. So which means the tan angle of theta will be equals to the opposite is H all over the adjacent is X that we are looking for, because we want to find X before the H. So we'll make this over 1 and cross multiply. So H times 1 will give us H is equals to X times this will give us X tan theta. But already the theta was given as 60 degrees. So it means our H will be equals to X, the tan angle of 60 degrees. So we are through with that small triangle. So we are going to call this equation 1. We are done with that. So we are going to now consider the big triangle. Please watch. So let's say considering, I don't want to wipe out this because the options have been given, so that at the end of the day we'll see if we have any of the options correct. All right, so we are now considering the big triangle. We are considering the big triangle PAC. That's the big one, PAC. We want to consider the big triangle PAC. All right, and in that big triangle, this is what we have. So here we have the big one, we have 30 degrees. All right, here we have PAC. Then from A to C, we have 25 plus X. From A to C, we have 25 plus X here. So 25 plus X is what we have. And then here we still have the height. Of course, that's the height. All right, so the tan angle of theta, because the only trig functional identity that relates the opposite to the adjacent is tan. So the tan angle of theta will be equals to opposite all over adjacent. So our tan angle of theta, the theta is now 30 degrees, will be equals to the opposite, that's H. All over the adjacent is 25 plus X. 25 plus X. So we'll make this over 1 and cross multiply. H times 1 will give us H is equals to this times this will give us 25 plus X. The tan angle of 30 degrees. So that's what we have. So you can see that we have defined H. We have defined H here. Here will be equation 2. Please take note of that. So from equation 1, we have that H is equals to X tan 60 degrees. And from equation 2, we're given that H is equals to 25 plus X, the tan angle of 30 degrees. These two equations are defined in terms of H. And since H equals something and H equals something, it means we can equate the two equations, because the two equations have one parameter that is common, which is H. If you say that 5 is equals to X, and at the same time you say that Y is equals to X, because you have mentioned X and X, it means that these two parameters are equal. Therefore, it means 5 is equals to y. Please take note of that. If you say that 5 is equals to x, and at the same time you say that y is equals to x, maybe this one is equation 1 and this one is equation 2. It therefore means that since 5 equals x and y equals x, 5 and y are equal. That's what we want to apply here. It's that simple. So that's the way to handle it. Okay, so let's see how we can handle that. Let's see how we can do that. Okay, so let's take that here. Okay. All right, so now from equation 1 and 2, from our equations 1 and 2, now we're told that h is equals to this and h is equals to this. So we equate this to this because h is equal. So let's equate that. It therefore means that x tan 60 degrees or is equals to this. Our x, the tan angle of 60 degrees, is equals to h, which of course h is equals to this. So that will be 25 plus x tan 30 is equals to 25 plus x, the tan angle of 30 degrees. All right, so by so doing, we are going to find the value of x because x is now common on both equations. So let's see how we can handle that. Okay, so we have that x tan 60 is equals to 25 tan 30. We want to expand. 25 tan 30 degrees plus x tan 30. So we are trying to expand. X tan 60 degrees is equals to 25 will times tan 30, which is what you have here, plus x will times tan 30 degrees, which is what we have here. All right. Okay, so we are going to have that our x now, x tan 60. This will cross to be the brother here, minus to become minus 25 tan 30 degrees. Of course, that will give us just x tan 30. Please watch this. All right. So x tan 60 degrees. And then we have 25 times will cross to give us this. But if you look at it, when you cross this, I want to show you something by doing this. When you cross this one to this side, you will notice that you have x and 25. So it won't work for you. So it's better for you when you have the x tan 60 and when you have the x tan 30, the x should come together. So I'm going to cross the x. That's what I'm going to do. I just wanted to show you something. So if you have x tan 60 degrees, this x tan 30 degrees will cross to be minus x tan 30 degrees. So that you have the x and x together is equals to, this is left, which is 25 tan 30 degrees. That will be left. And we want to find the value of x. So we factor out x. We want to take x, we'll factor it out. So if you take x out, what do you have? Tan 60. Tan 60 degrees minus tan 30 degrees. So we have factored x out. This x and x is taken out. So you have tan 60 degrees left minus tan 30 degrees left because the x itself is out. So this will be equals to 25, the tan angle of 30 degrees. So we can easily find x now. X will be equals to 25 tan 30 here, 25 the tan angle of 30 degrees divided by the bracket here, which is tan 60 degrees minus tan 30 degrees. So we are going to get the value of x. It's simple. So finding the value of x here, it means we are going to have the value of x to be equals to 25 times, they've given us the tan angle of 30 degrees to be 0.58. 0.58 was given as tan 30 degrees. All over, so what do we have here? Tan 60. Tan 60 was given in the question as 1.73. 1.73 was given minus the tan angle of 30 degrees, which is 0.58. So that our x will be equals to, so we have 25 times 0.58 will give us 14.5 all over 1.73 minus 0.58. So you have 1.15. Now our x will simply be to divide 14.5 divided by 1.15, and that will give us 12.6 meters to the nearest meter, which is approximately 13 meters to the nearest whole number. All right, so we have been able to find x. And what is that x? X is the distance from B to the foot of the cliff, which is the first thing we say we should find. The distance from B to the foot of the cliff. Therefore, the distance from B to the foot of the cliff, is approximately 13 meters. So we are through with that. The distance from B to the foot of the cliff. Now the next part, this is now very easy for you now to find the height. Because we have been able to find the distance from B to the foot of the cliff, which is x. With that, we can get the height. All right, so to get the height, for us to have the height, we want to now consider only the small triangle. So considering just the small triangle, where we have this as 60, all right? We have already calculated x here. Now we have calculated x as 13 meters or 12.6 before. Let's use the old one, 12.6. When we are done, we can now approximate the final answer. So we'll be able to complete this as 12.6. It's easy for us to have the height now. And remember that when we consider the small triangle, we said that we define the height in one of the two equations. In equation 1, we're able to define the height. If you go back to equation 1, we said x tan 60 degrees is equals to the height. That's what we said. And in equation 2, we said 25 plus x tan 30 degrees is equals to the height. So from equation 1, we were told that x tan 60 degrees is equals to the height. That's what we see in equation 1. So you can either use the equation 1 or the equation 2 to find the value of h. Any of the two equations, whatever you use to find the value of h, the answer will still be the same, because h was defined as x tan 60 degrees in equation 1, and h was defined as 25 plus x tan 30 degrees in equation 2. So using any of the two equations, you can find the value of the height, because the height was defined in terms of x, and now we have calculated the x. So x tan 60 degrees is equals to the height. What is our x? The x has been computed as 12.6, which was 13 approximately, but we'll use the 12.6, which is the number that is unapproximated. So when we get to the answer, we can now approximate. All right, so our x now is 12.6 times the tan angle of 60 degrees was given as 1.73. So that will give us the height. So 12.6 times 1.73 will give us the height of 21.7 or 0.8. So that will give us 21.8 meters. Now they now say to the nearest meter. Therefore, our h will be equal to the nearest whole number. 8 to approximate 21 to become 22 meters to the nearest whole number. All right, so this was the II. This was previously the I. All right, so we've been able to have this. And of course, if we go to the option where we have 13 meters and 22 meters, 13, 22, okay, that's option D. So you see that if you miss your approximation, you might have any of this. Somebody who misses this approximation might take 12, 22. Or you might have 13, 21 if you miss the second approximation as 21. So any of these can confuse anybody that the option is either of these, but the correct option is 13 and 22 meters, which is what we have as the D part. So you can see it's quite easy for you to solve a problem that has to do with angles of either elevation or depression using the two-dimensional problem when you have two angles that are given. But don't forget, like I said, if you want to find the height, the second option, you can use any of the two equations to have it. It's that simple. You can use it. Which means that even if you use this other one, you will still have this 22 meters. I think we should try that so that you understand that even if you miss out and you say, okay, let me use equation 1 or let me use equation 2, because in exam, some students might use equation 1, some might use equation 2. They will still have this height for the second one. Okay, let's see how that is true. Let's see that is true. Assuming we were to get the height, or let's say we want to use equation 2. From equation 2, we were told that 25 plus x, the tan angle of 30 degrees, is equals to the height. That's what we were given. We want to see whether from equation 2, we'll still have the correct answer for the height. So 25 plus, what is the x? We calculated x here as 12.6. 12.6. Alright, so we want to times by the tan angle of 30 degrees, which is 0.58. Would that still give us the same height? So 25 plus 12.6, 25 plus 12.6 will give us 37.6. 37.6, we want to times it by 0.58 to have the height. So let's multiply 37.6 times 0.58. What will you have? 21.8. So you have 21.8 meters to be equal to the height, which is approximately 22 meters to be equal to the height. So you can see that whether we use the first equation or the second equation, you will still have 22 meters, which means that the moment you have calculated your x, it's easy for you to get the height, either by using the small triangle or the big triangle, which is either by using equation 1 or equation 2. The height will still be the same. All right, so please, you have to systematically sit down, look into this question, and look at it one point to the other and see how simple it is to solve. It's that simple. If you can do this, there is no question on angles of elevation and depression you won't be able to solve, because this is the highest scenario, the worst scenario you can meet. You can be able to solve it easily. All right, so it is that simple. Thank you very much for watching our slide, Angles of Elevation and Depression Part 2. Until we meet next, I still remain your host, Mr. Mike Omeni. And please don't forget, if you have not subscribed to our channel, kindly do that by clicking on the red subscribe. And if, of course, you have any question whatsoever to ask in this slide, please do that by going to the comment section to drop your question and we'll respond. And if you enjoyed our class, you can give us a good comment with regards to the class, Angles of Elevation and Depression, Part 2. And again, please don't forget, subscribe to the channel to enable you watch every other video or every other slide in mathematics, because our aim is to make you a professional math. And a professional mathematician is one that is acquainted with almost every topic in mathematics. God bless you. Until we meet again, have a wonderful day. Cheers.